Let's now look at how we can detect the pH of a substance. What we need to use to do that is what we call a chemical indicator. And chemical indicators detect the presence of acids or bases by undergoing a distinct observable change. It's a predictable change. And you all, I am sure, have used pH paper. Perhaps you've used other indicators that could be in liquid form. I'm going to be demonstrating an example of that. Let's look at the common pH indicators that we are going to find in Table M. And we've got 6 of them listed here. These are the indicators. They have the approximate pH range for color change, and they're going to tell you what that color change is. So the indicator known as methyl orange is going to change color somewhere between this pH range of 3.1 to 4.4. And what it's going to change from is from red to like an orangey color to yellow. So it's going to be red below a pH of 3.1, and it's going to be yellow, if you could see that, above a pH of 4.4. And in this pH range here, it's going to be a kind of orangey color, some intermediate color there. So if I place methyl orange in a pretty strong acid that is below 3.1, methyl orange will appear red. If I place methyl orange in a pH of 4.0, it will appear orangey. And anything above that, any substance above pH of 4.4, it will turn yellow. The demonstration I will be showing you will be for phenolphthalein, one of my favorite indicators. You're going to notice that it actually has a pH range for color change between 8 and 9. So phenolphthalein is colorless below a pH of 8, and it's a very bright pink above a pH of 9, and it could be like a very pale pink. So I'm going to demonstrate one of my favorite pH indicators, and the indicator is known as phenolphthalein, and it is found in Table M right here. And we're going to test it with sodium hydroxide, a strong base. I'm also going to use another indicator, and this is just pH paper or p hydrion paper. Please be aware, this paper is a high quality paper that has been infused with chemicals that will change color in predictable ways based on the pH. So that's why we have all these pretty colors here. And I'm going to leave that out so we could see this will, it's got a pretty wide range to test. Now, what I would like you all to do is to jot down your observations and the pH that we observe. Now, in the center here, I've got tap water. I'm taking that tap water, placing it on that pH paper, and let's see what we get. So plain tap water, we're looking at, I would say that's pretty close to a 6. And by the way, that is fairly normal. Tap water is usually, and rainwater by the way, is usually very slightly acidic, and pH of 6 is common. Remember, water having a pH of 7 really has to be distilled or pure water, and this is not pure. Now, the phenolphthalein, let's test the pH paper with my phenolphthalein. indicator. Just gonna need just a few little drops. There we go. I'm gonna try to leave that up there. And you're gonna see here that phenolphthalein looks like at about a 6 as well. So our observations is that tap water has a pH of 6. Phenolphthalein in that tap water will have a pH of 6, because I just tested it separately, but I'm going to put a bunch in there, by the way. And you're going to notice, by the way, really actually hard for you to see in this bottle, but this is a clear liquid. It looks just like water on its own. It kind of looks kind of a little cloudy in there with that water. I put a lot in. And the typical description of phenolphthalein is to be a colorless liquid. And our tap water is colorless as well. Now, my sodium hydroxide solution, I'm going to test it separately, and then I'm going to place it in this mixture. But let's see what we have for pH. I'm just going to use a little bit here. You're going to have to trust me. I've got my goggles on. And notice it's colorless as well. Ooh, there we go. I'm putting it on that pH paper, and I'm seeing quite a dramatic dark color. I'm going to put that at about pH of 13. I'm going pH of 14 for the NaOH alone. Okay. Now I'm going to take some of this sodium hydroxide, and as a reminder, this has a pH of 6 because we know it's got water and phenolphthalein in it. We're looking at a pH of 14 for the sodium hydroxide alone. When I place sodium hydroxide in, whoa, check that out. That is so pretty. I love it so much. I'm not even going to add any more because that is dramatic. That is gorgeous. And this is why I love phenolphthalein. And I can kind of swirl it about. And what we have is pink, bright pink, very bright pink. And this is the typical color that we're going to see phenolphthalein become under certain circumstances. Let's look at our chart for a moment. Phenolphthalein was colorless at a pH of 6, which makes sense there. It's below pH of 8. It becomes pale pink at 8 to 9 and bright pink at a pH of 9. I wonder what pH this is, the combination. Now I know the sodium hydroxide alone was very strong at a pH of 14, but I wonder what this is. Let's test that out. We'll dip that in there. I didn't really mix it well, so let me do that a little bit. Okay. And kind of, it's got a mixture of colors there, but it's kind of bluish looking to me, right? You see that? So I'm saying maybe around 11, pH of 11, which does make sense because we're above 9 and we're going to bright pink. Is a pH equals 11 for all three of those. Now, just to add a little more fun to my demo, have any of you ever had heartburn? I have, rarely, but it's not fun. It really is painful. And one substance you could take is Alka-Seltzer. And Alka-Seltzer counteracts the acidic heartburn. Remember, this has nothing to do with your heart, by the way. It's the acids from your stomach getting into your esophagus, kind of burning the esophagus lining a little bit. So your stomach's normally acidic, but when you have heartburn, that acid leaves the stomach a little bit and starts burning the esophagus or the tube leading to the stomach. And so one way to counteract that strong acid, or in this case, a pretty strong base, is Alka-Seltzer. This is a good buffering system. And when we place that in there, it starts to act right away. And wow, isn't that cool? It's totally neutralizing that base. And in our last lesson, we talked about neutralization reactions, right? If you mix an acid with a base, you're going to get a salt and water. I mean, this is a little more complicated than that, but it's the same general idea that Alka-Seltzer is a buffering medicine, so it's going to bring an acid or a base closer to neutral. Not exactly there, but closer to. So I bet you when we test this, because our phenolphthalein has gone back to its original color, I bet you when we test this, pH, where are we at again? 5-ish, 6-ish. I would say 6, right? So this Alka-Seltzer worked well. It's colorless. It's a pH of 6. Pretty cool, huh? Hope you enjoyed this acid-base indicator demonstration and you were able to see the color changes that occurred depending on the environment that the phenolphthalein was in. I hope you enjoyed this demo. Have a great day. Bye.